You want to stay informed, but keeping up with tech news, it feels like a full-time job sometimes, right?
Absolutely. It moves so fast.
Exactly. So that's what we're here for. Today, we're doing a deep dive into three really interesting areas. Well, what's next for graphics from Intel and AMD, a new SSD from SanDisk that sounds incredibly fast, and AMD's new server chips, the EPYC ones, but aimed right at small businesses.
Yeah, quite a mix.
Our goal today, to cut through the noise, pull out the key insights, and really figure out what these shifts mean, especially for performance and accessibility in tech.
Okay, so let's start with the graphics side. It's always fascinating to see what Intel and AMD are cooking up for their next-gen GPUs. We're seeing code names pop up. Now, Intel's got XE4, which they're calling Druid, and AMD has GFX 13.
Druid, huh?
Okay, yeah. And while obviously the details are scarce this early, just seeing these code names tells us development is definitely active. They're working on the future.
Right. And for Intel, it fits their pattern, doesn't it?
Yeah.
We had Alchemist, their first real go, then Battlemage. XE2, that launched, December last year? And next up is Celestial, XE3. That's the one we're kind of expecting alongside their Panther Lake CPUs later this year.
Or maybe a bit after.
But the really interesting bit, I think, is that even though Celestial isn't out yet, Intel's already shifted engineering focus to designing Druid, the XE4 architecture.
Which tells you something about the timelines involved. Celestial, right now, is in what they call pre-silicon validation.
Okay, what does that mean exactly for people listening?
It basically means the hardware design, the blueprint, is finalized. Now the teams are heavily focused on the software, the firmware, testing, refining, basically making sure everything works before they actually manufacture the physical chips.
Gotcha. So hardware done, software focused now.
Exactly. And given that Celestial is probably looking at a 2026, maybe 2027 release, we can sort of guess where Druid lands. If they stick to a typical cycle, we're likely talking 2028, maybe even later for XE4 to actually hit shelves.
Wow. It really emphasizes just how long these development cycles are for high-end graphics, years in advance.
Definitely. Huge planning involved.
Okay, so turning over to AMD now. They use that GFX naming scheme. GFX 13 is the next one up.
Right.
But the marketing name, that's still a bit fuzzy, isn't it? Could be RDNA 5 following the gaming line, or maybe this new UDNA thing, UDNA 1.
Yeah, that UDNA idea is, it's quite interesting. AMD has been dropping hints about maybe unifying their gaming architecture, RDNA, with their Compute 1, CDNA.
Okay.
Putting them under one roof, potentially called UDNA. It kind of reminds me, actually, of what NVIDIA did for a bit.
Oh, yeah? How so?
Well, remember Ampere? That architecture spanned both their gaming cards and their data center stuff.
Right, the 30 series GPUs.
Exactly. Then later, they split them out again with Hopper for compute and Ada Lovelace for gaming. So AMD might be looking at a similar unified phase.
Okay, so if AMD does go down this unified UDNA path, what are the pros and cons for users? What could it mean?
Well, the big potential upside is probably simpler development for AMD. One core design you adapt for different things could be more efficient, maybe faster to iterate.
Makes sense.
But the risk, or the question maybe, is about trade-offs. Gaming performance and high-performance compute have pretty different needs, right?
Different optimizations.
Yeah, so a unified architecture might have to compromise somewhere. Maybe it won't hit the absolute peak in gaming compared to a totally dedicated RDNA design, for example. It's a balancing act.
So timeline-wise, for AMD's GFX 13, if they stick to their usual cadence, what are we thinking?
If they keep that rough 2-year cycle going, we could see desktop cards based on GFX 13, whatever they call it, maybe late 2026, early 2027, perhaps.
Still a couple of years out then.
Seems likely.
It's wild thinking about these powerful chips being, still years away on the design bench.
Yeah.
But it definitely signals that the big players are constantly pushing. Good news down the line for gamers wanting more frames and pros needing that raw power.
Absolutely. Long-term view.
Okay, let's pivot to something we can almost touch now, storage. SanDisk just dropped news about their WD Black SN8100 SSD, and they're not being shy, calling it the world's fastest.
Yeah, that's a bold claim, but the specs are. Oh, there's something else. It's a PCIe Gen 5.0 NVMe drive, and the big number is that read speed, up to 14,900 megabytes per second.
14,900, wow.
Just massive throughput, and they're offering it in capacities up to 8 terabytes, too.
8 terabytes. Okay, you can see who that's aimed at. Gamers with huge libraries, obviously. Content creators wrestling with 4K, 8K video.
AI work as well, anything needing super fast data access.
And they're also talking about power efficiency. claiming double the efficiency of their last-gen PCIe 4.0 trides.
That's what they're saying, yeah. Which is pretty significant if true, especially for laptops or even just keeping temps down in desktops.
So what's the magic behind this? What's the tech allowing these speeds and efficiency?
It's based on SanDisk's newest NAND flash memory. Specifically, it's called BiCS8 TLC 3D CBA NAND.
Okay, break that down a bit. BiCS8?
So BiCS is their 3D NAND tech, stacking memory cells vertically. Higher density, faster speeds. TLC means triple-level cell, storing 3 bits per cell, a good balance of cost, performance, and endurance. And the CBA part refers to how the layers are connected, circuit board attached, which helps boost performance further.
Got it. And the write speeds are keeping up.
Pretty close, up to 14,000 millibreeds sequential write. So yeah, it looks like it'll be right up there, maybe even challenging the current speed champ, the crucial T705.
But it's not just about those big sequential numbers we always see advertised, is it? Random performance is key for that snappy feeling.
Totally critical. Yeah, loading apps, multitasking, dealing with lots of small files, that's random I/O. And SanDisk is claiming up to 2.3 million IOPS.
Million.
Yeah, input-output operations per second. That's for the 2TB and 4TB models. That's incredibly high and should translate to fantastic real-world responsiveness.
And the power draw to achieve that.
Surprisingly low, actually. They're quoting an average draw of just 7 watts.
Only 7 watts. For that kind of performance, that's genuinely impressive.
It really is. It suggests they've really focused on optimizing efficiency alongside raw speed. This thing looks tailor-made for people who just need the absolute fastest, most reliable storage for really demanding work.
So yeah, the takeaway is the SN8100 isn't just a small step. It seems like SanDisk is really trying to push the whole market forward for consumer SSDs.
Yeah.
Could be a proper game changer for enthusiasts and pros.
Definitely one to watch when it launches.
All right, let's move to our final topic, AMD's new EPYC processors, the 4005 series. Now, usually EPYC means huge data center chips, right? But these seem different.
You nailed it. These new ones, codenamed Grado, are specifically built for a different market. Entry-level, single-socket servers.
Okay, so like small businesses.
Exactly. Small businesses getting their first real server, maybe edge computing setups where you need processing closer to the action, or hosting providers wanting cost-effective options.
And interestingly, they're using the AM5 socket,
Yeah.
the same one as their desktop Ryzen chips.
Yeah, that's a key point. AM5 socket compatibility, which is quite unusual for an EPYC branded product.
So what does that mean for performance? Are these just rebadged Ryzen chips or
They definitely share DNA. They go up to 16 cores and 32 threads.
15 cores? That's quite a bit for entry-level server.
It is, and apparently that core count lines up nicely with licensing for Microsoft's upcoming Windows Server 2025. Smart move there.
Oh.
Architecturally, they are very similar to the new Ryzen 9000 desktop chips. Based on Zen 5, using 2 of those 8-core chiplets, lots of cache too, 8 MRBL2, 32 MRBL3 per chiplet.
And is there a V-cache option, like on some Ryzens?
Yep, the top model, the EPYC 4585PX, includes 64 MB of their 3D V-cache stacked on top. That can give a serious boost in certain workloads that love cache.
What about memory? Server stuff usually needs ECC, right?
Absolutely, and these support it. Dual-channel DDR5 5600 with ECC error-correcting code memory, crucial for server stability and data integrity.
And power, what are we looking at?
It varies by model, but the range is from a pretty modest 65 watts up to 170 watts for the top-end parts.
Okay, and security. That's always huge for business servers.
They seem well covered there. AMD's including things like Trust Zone, Secure Boot, TPM 2.0 support, and memory encryption. All the standard enterprise-grade security features you'd expect.
Activity.
Pretty modern. 28 lanes of PCIe 5.0 for fast storage or networking cards, software RAID support, and even modern display and USB ports, which might be handy for some edge use cases or just setup.
So AMD's angle here is clearly about bringing that higher performance down to smaller businesses that maybe couldn't afford traditional EPYC before.
That's exactly the message. Someone from AMD, Derek Dicker, mentioned addressing budget and deployment hurdles for growing businesses. They're aiming these squarely at Intel's comparable offerings.
Which would be?
Intel's Xeon E2400 series and maybe some of the lower-end Xeon 6300P parts. And a key difference is core count. Those Intel parts top out at 8 cores currently.
Ah, so AMD is bringing potentially double the cores.
Potentially, yeah. And AMD released some benchmarks comparing their 16-core EPYC 4565P against an 8-core Intel Xeon 6369P. And AMD claimed an 83% performance advantage.
83%. Wow.
Man.
The price.
Very competitive. That specific AMD chip was listed at $589, while the Intel one was slightly more at $606, according to AMD's numbers.
So significantly more performance for slightly less money. That's a strong pitch.
It really is, assuming those benchmarks hold up in real-world use, of course.
What about software? OS compatibility.
Besides Windows Server, they're compatible with the big Linux distributions Ubuntu, RHEL, SUC Linux, so plenty of flexibility there.
And where will people actually buy these in servers from?
Major OEMs like Lenovo, Supermicro are on board. Retailers like Newegg will likely carry systems too. We should see them in various server form factors, from standard racks to smaller boxes.
And the price range for the chips themselves?
Starts at $289, goes up to $699 for that top 16-core V-Cache model.
Okay, so the bottom line here is AMD is leveraging their latest Zen 5 tech, the AM5 platform, to really attack that entry-level server market, offering potentially a lot more performance and cores for the money compared to the competition.
That's the gist of it. Strong performance, solid security, and cost-effectiveness aimed right at smaller organizations needing to upgrade their IT.
It really feels like they're trying to make those enterprise-grade features more accessible. Could definitely empower smaller businesses.
Yeah, giving them more horsepower without breaking the bank could help them handle bigger tasks, be more efficient, position themselves for growth.
So, wrapping up this deep dive, we've peered into the fairly distant future of GPUs with Intel's Druid and AMD's GFX 13.
Years away, but showing the direction.
We looked at the very near future of storage with SanDisk's blazing fast SN8100 SSD.
Setting a new potential benchmark there.
And we examined AMD's strategic move into the small business server space with these new AM5-based EPYC chips.
Bringing a high core counts down market.
It really makes you think, which of these areas might actually impact your tech world the most? Are you waiting for that next GPU leap, desperate for faster storage, or maybe managing IT for a business where those new EPYCs could be a perfect fit?
Yeah, everyone's needs are different.
And maybe a final thought to chew on. We keep seeing the lines blur between consumer tech and enterprise tech, right? Like these EPYCs using a desktop socket.
Definitely.
So how might a breakthrough in one area, say gaming GPUs or consumer SSDs, unexpectedly ripple out and maybe even revolutionize the enterprise space or vice versa in the next few years?
That's a great question. The cross-pollination is definitely happening more and more. Something to keep an eye on.
Absolutely. Definitely something to ponder until our next deep dive.